Hello children, welcome back to Insight Engine Academy. So this is physics class, chapter 8, physical sciences, first chapter force. So we have discussed types of forces, contact force, non-contact force, right? So in those types of contact force, different types of non-contact forces we have discussed. In the last two videos we have discussed how to draw the free body diagram, and with the help of that free body diagram, how to calculate the net force. Okay, so everything we have discussed, right? Now the last topic of this chapter, pressure. So what is pressure? So generally pressure is related with this change in effect of force with area of contact. Okay, so that means what? Here this pressure, especially in the relation between the force and area. Okay, when we relate between the force and area, we get the pressure. How? See, pressure is equal to force by area. Okay, so our lesson is related to force. Okay, when force increases with area unchanged, the pressure also increases. Okay, so pressure, it is a new physical quantity that we are talking about. What is pressure? See, so I am going to apply some force on this board, right? So I am exerting force on this area. The force acting on a particular unit area is called pressure. Okay, so pressure is nothing but force acting on unit area of surface is called pressure. See, we will understand the relation between the pressure, force and area. Pressure is denoted by the P, force denoted by F, area denoted by A. This is the mathematical expression. Pressure is equal to force by area. Now we are going to write the SI unit of the pressure. Force SI unit already we have discussed in the last video, Newton. Area, it's a two-dimensional measurement. Its unit is meter square. Okay, so the SI unit of the pressure is Newton per meter square, or sometimes in some cases we say Pascal also. Okay, so these are the SI units of the pressure. So pressure is equal to force acting on unit area. Okay, generally when you're riding the bicycle, for understanding this definition, now I am giving some examples. Whenever you're riding bicycle, what happens when wind blows opposite to you? Can you ride your bike comfortably? Can you ride your bicycle comfortably? Okay, does it move forward easily? It is difficult to move forward. You have to apply more force on the pedals, then only you are able to move your bicycle forward. Yes, sir? So here wind is blowing. The blowing wind exerts some force on your area of body, surface of your body. So what happened? It is opposing our motion. That is called pressure. That is air pressure. We feel air pressure. Okay, and when do we feel air pressure? See, whenever we get sick, whenever we become sick, we fall ill, we go to meet the doctor. Okay, so doctor usually measures blood pressure and also as usual temperature, right? So whenever he measure the blood pressure with the help of the sphygmomanometer, okay, so he tie that complete around our shoulder. Okay, when he press that bulb, the gas enters and pressure increases on our hand. We feel pressure is increasing, right? So that is the best example for understanding pressure. That means what? Pressure is nothing but force exerted on unit area. So this is your area of shoulder. On this area, force is exerting. So you are feeling pressure. So pressure is equal to force by area. So this is the best example for understanding the pressure. Okay, right. So if you take one balloon, another example we'll discuss. If you take one balloon, if you inflate the balloon, when we blow the air, the balloon inflate, right? So if you take the inflate balloon, when you try to pierce with the finger on the balloon, what happens? You feel some pressure, right? Because air inside the balloon exerts some pressure, right? Yes. So all these are the examples of understanding pressure in our daily life, right? So pressure you understood. Pressure is nothing but force exerted on unit area. That is called pressure. This is a mathematical expression, and these are the SI units of the pressure. It is clear. Okay, now how pressure increases and pressure decreases? Here we have to relate this with force and area. So in case 1, I am keeping force constant. Keeping force constant. So actually what is the formula? Pressure is denoted by P, force is F and area is A. Now we are taking F is constant. F does not change. We are not changing the force, but we are changing the area. By keeping the force constant, if area changes, then pressure also changes. And then what is the relation between this pressure and area? They are indirectly proportional. So P is nothing but P by 1. So So P is the numerator of the first fraction, A is the denominator of the second fraction. As usually, we find inversely relation between this pressure and area. When area increases, pressure decreases. When area decreases, pressure increases. Okay. So pressure depends on what? Area as well as force. But here force we are keeping constant. How this pressure related to area? So pressure is directly, indirectly proportional to area when F force is constant. What are the examples? See, if I take one pen, okay, so this is the area of contact. With this area of contact, I am going to press on my finger. I don't feel anything, that much pain. I don't feel any much pain. Okay, same force I exert, but this time you see the nib of the pen has smaller area. Okay, now you see same pressure, but I feel some pain. Same force, but I feel pain. But previously, even though apply the same force, not same force, more force also, see, I am not able to feel any pain because here area is more. But here, when I reverse the pen, when I press with the nib of the pen, area is less. So I feel more pain because this smaller area exert more pressure on my finger. This larger area exert less pressure on my finger. Okay. And whenever we try to hit the nails into the wall with the help of the hammer, generally what happen? How do you do this? Okay, the sharper and smaller end of the nail generally kept on the surface of the wall, and with the help of the hammer the wider end will be beaten. Okay, then what happened? When area is less, that one has less area, so due to the more pressure, that nail able to penetrate into the wall. If you do reverse, if you keep the nail in the reverse manner and if try to hit, what happen? It doesn't enter and nail will bend also. Yes sir. So best example, previously we have discussed, take one inflated balloon. Okay, blow the air, the balloon automatically inflate. Now try to press with your finger, that balloon doesn't burst. But take this kind of pen or pin, what happen? If you press, the balloon burst. What is the reason? So this small pin exert more force on the balloon, but this finger with more area, less the pressure. This finger doesn't exert that much pressure on the balloon, so balloon doesn't burst. But if you take this pen, okay, area is very small, so this smaller area, when area decreases, pressure increases, so balloon burst. Okay, some other daily life examples we will discuss regarding this. Okay, so every vehicle has tires, cycle, even a bicycle, electric motors. Okay, automobiles, jeep, car, lorry, all these are automobiles, right? All these automobiles generally they have tires, right? See, have you ever seen the tire size of the lorry or truck? Yes, you have seen. Have you ever seen the size of the scooter, okay, or bike? Yes, you have seen. If we arrange the tires of the bike, same size tires to the lorry or truck, what happened? The tires will burst. What is the reason? Because these tires, bike tires, have smaller area. When area decreases, pressure increases. On those tires, the heavy body exerts more force. Due to the decrease in pressure, the tires experience more pressure. Okay, even though the force is constant, the truck exerts same force. But instead of that smaller tires, okay, instead of that smaller tires, if you increase the size of the tire wide, these are the grooves on the tire, right? If you increase the size of the tire, that means area. When area increases, same tire experience less pressure. I hope you understand. That is why the truck and heavy loads, okay, trucks which carry heavy loads, they have the wider tires. Okay, so the porters who works in a railway station, railway coolie, okay, so generally when any train enters that station and halt, some people or passengers get down from the train, right? And these people usually they carry the luggage from one place to other place, right? So while they are carrying the luggage over their head, what do? They take the towel and they just keep on their head and they will just carry the heavy luggage on them. What is the reason? Because when the area of the towel increases, there doesn't feel much pressure on the head. When area increases, pressure decreases. So without that towel, okay, they surrounds the towel around the head. Okay, so when they tie the towel around the head, if they remove that towel and if they carry the same luggage, area decreases, then what happens? They feel more pressure on the head. I hope you understand this concept. Okay, and also coming to another important example for this, cutting vegetables. So vegetables generally we cut with our, generally what is the tool we use to cut the vegetables? Yes, knife. Okay, so knife has two edges. One is the blunt side, other one is the sharp side. Okay, if you try to cut the vegetables with the blunt side, the vegetables it doesn't cut. What is the reason? Because the blunt side, the surface area is more. When area is more, that knife doesn't exert that much pressure on the vegetable. Sufficient pressure not exerted, so the vegetable unable to cut. If you try to cut the vegetable with the sharp side has less area. Surface area is very less. Due to decrease in the area, pressure increases for the same amount of force applied. Then what happen? The vegetables cut easily. Even scissors also. Axe. So farmers generally use axe. Okay, in olden days, some people also in olden days, nowadays we have LPG cylinder, some other induction stove, electric induction stove, electric rice cooker. There are many. But in olden days, generally people are cooking with wooden oven. They generally go to forest and they cut down the trees, wooden, dry wood, and they carry home and they will try to, with the help of axe only they cut the wooden trees, right? Those days, right? How axe should be sharper or blunt. So blunt axe doesn't cut the wood. Sharp axe cut the wood. What is the reason? So sharp axe, okay, the edge which is sharp, area is less. So pressure increases. That axe can exert more pressure on the wood, then wood will break. If you do with the same blunt axe, it takes more time. Our energy also wasted. Okay, I hope you understand this relation between the pressure and area when force keeping constant. For the same amount of force applied, when area increases, pressure decreases, area decreases, pressure increases. Okay, so there are many examples, right? These examples just now we have discussed, and some other examples we are going to talk related to the case 2. What is case 2? Now in case 2, keeping area is constant. Keeping area is constant. Now I am going to keep area constant. What is the pressure formula? Force by area. So in this case, area is constant. Area is constant. Okay, area doesn't change. Area is fixed. Then what is the relation between this force and pressure? So they are directly proportional. Okay, so pressure is directly proportional to force when A is constant, area is constant. When force increases, pressure also increases. Okay, a simple example just now what we have discussed. See, so now I am going to try to pierce with the help of this nib of the pen on my finger. Okay, when I am exerting less force. So pressure also less. Now I am going to apply more force, then pressure also more. Okay, when force increases, pressure also increases. Here area is constant. This area of the nib is constant. So when area constant, by keeping the area constant, how can you increase the pressure? By increasing the force. By keeping the force constant, how can you increase the pressure? By decreasing the area. So this is the main relation between the pressure, force, area. Okay, so pressure is equal to force by area. This is the one of the important formula. Okay, so we will solve 1 or 2 problems related to this. Okay, please note down meanwhile the definition and this important concept.